And now we do 5.5, trigonometric equations. Last section in chapter 5 that we're going to deal with. So it says essentially the rules are very simple. We're going to solve an equation. I put 4 of them here, and let's see how, or 5 of them here, see how this works. So it says solve for x, 2 cosine x plus 1 equals to 0. Now, you want to find the answer between 0 and 2 pi. So that means you don't want all these other answers. So you move stuff around like an equation. Subtract by 1. 2 cosine x equals negative 1. And then essentially, again, you cancel like an equation. Then divide both sides by 2. Cosine of x equals negative 1/2. Then you take cosine inverse. You do cosine inverse so that this can cancel. You're trying to get x by itself ultimately. Okay? So x equals cosine inverse of negative 1/2. So I go back to the training that we had with inverse trig. Now, cosine inverse of 1/2 is an adjacent of 1 and a hypotenuse of 2. That's 60 degrees. This is 60. But because it's negative, we're looking for an angle that lives in the second quadrant. 120 has a reference of 60, is 120, so 2 pi over 3. So now, as you look at the 4 quadrants, recall that you're looking for essentially any of the 4 quadrants where cosine is negative. Well, cosine is negative here, and cosine is negative here. We got this one is 120, that lives here. But now, what angle lives in the 3rd quadrant that has a reference essentially of 60? Well, that's 240. That's this dude. So now you're looking for more than one answer. You're looking for all the answers that fit in the quadrant. That's the difference now. So it's like when we're looking for just straight up cosine inverse. The cosine inverse of negative 1/2, if we were in the previous sections, in chapter 4, we would just have 2 pi over 3. But now we have to include all of them. So 4 pi over 3 as well. Number 2 is essentially a college algebra problem. This is kind of like second part is quadratic. So we're going to move the 1 back over here. So this essentially is kind of like, it's kind of like 2x squared minus x minus 1 equals 0. Kind of like how this works. So kind of like college algebra. So you have parentheses, you know, the 2x and an x, a positive 1 and a negative 1, except x now is cosine of theta. You have to factor this out. 2 cosine theta plus 1 cosine theta minus 1. Set each equal to 0. Now this thing says on 0 to 2 pi as well. So when we subtract 1 from both sides, you get cosine theta equals negative 1/2. But that was over here. So we solved it the same way as we did before. 120 and 240. But now one's answers in radians. And now 2 cosine theta equals to 1 when you add 1 to both sides, then take the inverse cosine. So theta is 0 now. Theta is also 360. But this thing, the parentheses, you can include 360. So 0. So the three answers are 2 pi over 3, 4 pi over 3, and 0. How you solve this? You have to factor. Now this one, you don't have to factor because there's only one trig function. It's not an extra cosine there or an extra sine. So this one says for x in general, wants all the answers. So add 1 to both sides and divide both sides by 2. Then take the square root of both sides. But now the problem is you're going to have plus or minus. So this is 1 over the square root of 2, which you simplify as square root of 2. So you have to look at the positive case or the negative case. Look at both cases because it's plus or minus. And then take sine inverse of both sides. So x equals sine inverse of square root of 2 over 2. So in essence, You're trying to figure out where is sine positive. Sine is positive in the first two quadrants. Sine inverse of sine 2 is 45 degrees, or pi over 4. So pi over 4 is an answer, and 135 is an answer, which is 3 pi over 4. So 45 and 135 are the answer to the first one, which is positive. In the last two parts where it's negative, what angle is in the third quadrant and the fourth quadrant, respectively, what has 25 as a reference? 225 and 215, aka 5 pi over 4 and 10 pi over 4. Now it wants all of the answers. You can spin as much as you want in all directions, so you're looking for all the coterminal answers. So plus or minus pi n, which is the period, or you're like adding, it's almost like coterminal, you're adding the period. You're adding the plus minus spinning 2 pi n. You have to add plus minus 2 pi n to all of them. You should have to think to revolve forever and ever, and you can have a bunch of answers. Correct, in general. Now we just said x from 2 pi. It's just those 4 answers. But because it wants all of them, you have to lock spinning. That's the idea of the coterminal angles, where you add the period or subtract the period. And now this one, know that there are two trig functions here with a minus in between. These two trig functions have cosine in common. So we're going to factor that cosine out, leaving tan theta minus 1. Now because these two have factored equal to 0, cosine is equal to 0, or tan minus 1 is equal to 0. Take inverse cosine of 0, you get 90 and 270 as the cosine is 0 in the first four quadrants, or from 0 to 360. And then sine inverse of 1, nomenclature sine is positive, or sine is it's inverse of 1, where sine is 1, is at 90 degrees, or pi over 2. And because it says for theta going from 0 to 2 pi, you stop. But if it said in general, you add plus or minus 2 pi n to each of these. That's essentially how it works. And then finally, tangent. So you add in the period if it needs. But this one says tangent now for x in general. Sorry for the arrow there. I kind of put it this way instead of up. But now add 1 to both sides, and then cancel tangent by bringing tan inverse. Tan inverse of 1 is pi over 4, or 90. So x minus pi over 4 equals pi over 4. Add pi over 4 to both sides, you get 2 pi over 4, or pi over 2. Now, because it's in general, you add or subtract the period. This is the period, or tangent. The period for tangent is pi. So in this case, you revolve each 180, 180, 180. That's its period for tangent. So plus or minus pi n. Notice for sine and or for cosine, you're adding or subtracting 2 pi n. If it's in general, you just get the answers that live in the quadrants. You don't add any plus or minus things to it. That's essentially how 5.5 works, and that should put us to the end of chapter 5.